Oh, I have to mute the stream that's coming back. All right, looks like we're alive. And another board needs to be done. This board is going to consist of the components that I have here. I'm going to be placing the components and routing the board. So let's get started. First of all, I have to kind of think through a little bit more in detail exactly how things are going to be connecting to this board. Actually, what I'll start with is just having these two windows side by side. So I can move these ones to a different workspace. Let's move this one as well. And then, let's see, let's move this one as well. And then let's move this one. See, come on, there we go. And this one will go to, let's see, can we do like this? Yeah, that's better. So now we can just change the size there. Just so we can click on this one, and we actually get the component there. We can also select the component here, and it will select the component in the PCB view, which is very practical. For example, I can select the diode, and I get it selected here as well. Let's start just placing things very roughly. So for example, I have the connectors that are facing upwards, so I can place them pretty close to each other, like this. And just actually, I'm not going to care about the silk screen for now. I'll just place the components because I'm likely to move them later. All right. All right. So now we have this chip. This can go there. Now we have all of these. Damn. We can actually just place them like this and then use the automatic placing functionality, or the alignment functionality to align them. Let's see. Oh, this one actually goes there. Let's see. And this one goes there. The way KiCad works when you do alignment is that, like, you can essentially just place the edge components far enough apart so that all the others will fit in between. But it's kind of hard to gauge the distance just by eyeing it. So I'll place them like this, and then I'll just select all of them, and I'll do align distribute. And distribute vertically. There we go. We should actually just also place the connectors in some appropriate way. Oh, that's just the ground, right? So this one, there it was. I missed this one. Okay. I have to realign them. Okay. Let's place them. Let's place them like this. Have this one there. This one is the second one, and then this one would be. It'll be good to change place. These two. Or maybe not. Actually, it's better like this. So also another thing, when I do layout, I sometimes realize that I have to rewire things to have cleaner routing, and then I do that. So occasionally I might actually do changes to the schematic, but usually not major changes, because at this point the schematic is pretty much done, and I don't want to make any major changes, so I don't have to review things again. But like minor rewiring can sometimes be very useful. So let's see. This one goes. Actually, maybe we should just place this one. Okay, actually, that's better. And this one can go there. So one of the very good things then with using device tree for the firmware is that it doesn't really matter how these ones are placed. We can always just rewire them for the software side without changing any code. Let's just do it like this. Now we should be able to please do it like this. This would actually probably work better with a grid. Alright. Yeah, grid was much better for this. Just place them on the grid. Alright. That'll be good wiring. Let's see, that's the test points, right? And just select all of the test points. I think. No? Can't do that. I wonder if there is a way to select all of the test points and just have them selected in here. Apparently just dragging like that doesn't work. So I'll have to take them one by one. So just place these test points right by the pins. I always find also having test points is a lot better than testing on the pins, because when you're testing on the pins, even if you can reach the pin, quite often it's hard to keep the probe precisely on the pin, because with all the solder, the probe actually can glide to the side and short with another pin. So I place test points instead. All right. If you're watching this live, feel free to ask questions in the chat. There we go. Where is this capacitor? This one will go as close to this pin as possible, but not inside the courtyard. Okay. And regarding the mount holes, I'm actually thinking I'm going to place them on the. Maybe it's actually enough with just two. I'm going to place two of them in the beginning of the board there. for now. I'm quite likely to change this. Okay, let's go to the next one. Next we have the CPU. Let's get the CPU here. Let's see. Interesting. So just clicking on that doesn't actually select it. That was weird. Okay. It selects it in the PCB view, but not in the schematic view. Very weird. Okay, so this one goes to pin number 1 here. And then we have this one. It goes to pin number 3. Yeah, that's better. That's this one better. Then we have the 10 picofarad capacitors here. Ideally, these crystals should be a little bit smaller because it's all the pins are very close together. They're just next to each other, basically. So next we have the boot resistor. And the other one. This one goes there. So actually I'm going to place this resistor a little bit farther away from the pin because I want to have a via or like a junction going to the boot pin on the connector. This one. The ferrite bead is probably not necessary. The thing is, like when we're using stuff like this on the KiCad schematic, so even though this is my idea is kind of to have this as a reusable block, which I can reuse on different schematics. But for example, if I don't use the ADC, then I can just replace this one with a 0 ohm resistor, and it could potentially be a little bit cheaper in terms of BOM. So I can do the modifications purely in the BOM. And if some component is not necessary, I just remove that component from the BOM. But having the footprints on the PCB allows for the possibility to use that component if it becomes necessary in the future. For example, like this RTC crystal. Right now, I don't think I'm going to be using it because I'm not going to be using the real-time clock. And actually, for most purposes, the internal oscillator, the one that runs from this crystal, from this one, the 8 megahertz oscillator, is precise enough to do most timing tasks. The RTC is only useful to if you need to measure exact time over over a period of maybe several hours. If you want to have a real clock that doesn't drift, then the RTC is very useful. Damn, this this cough is very dry now, so the more I continue talking, the more I cough. We'll see. Let's continue here. So we have this. This would be, which one is this? That's the capacitor. So this is a bypass capacitor. When placing bypass capacitors, you should place them on the same layer as the pin that it is connected to. Don't place any vias in between it. And try to place it as close as possible to the pin. So for example, here we have the ground, and we also have the 303. So we want to place it closer to 303, because the way we're going to connect ground here is directly to the ground plane. So it's going to be a via here going directly to the ground plane. And then the positive lead is going to go directly to the pin, and also to the positive ground plane, or to the positive plane, power plane, inside the PCB. So I'm going to be using an internal layer for the positive voltage. Let's see. Actually, let's set the. Let's see. Let's make this 4 layers. So I'm going to have internal would be power. Okay. Let's hide the fab layers and the silk screen layers. I usually take the silk screen last, because I don't want to mess around with the silk screen too much while I'm placing the components. Hello, Masood. How are you doing today? So this one goes to, let's see. Why is this not connected? It's connected to that, but not the hell. Pin number 9. Seriously, pin number 9 is not connected, apparently. Is this some kind of like a, let's see. Could this be because of misalignment of the grid? That is very strange. This should not happen. Why is this not connected? Interesting. Oh, now it's connected. Okay, so this one should be on this side. And here I want to place it a little bit farther away, because I have a lot of pins there that have to be led out. So I have to place it like this. Actually, I don't like the courtyard on this chip. I think it's too small. have to do for now. Let's place this like 3 grid cells away. Yeah. Okay. More capacitors. You have one here. Let's see if we can put a wire there. I don't think we can. It's pretty close. Okay. Like a 0.3 and 0.6. I did this wrong. This has to be 0.3 and this should be 0.6. There we go. So this will be the smallest wire, which should fit there. So ideally, we should have the courtyard on this chip so that it's so that any wires can fit inside that courtyard. Just one leading out the pins. So it'll be the minimum distance for all other components when placing components close to the chip. Okay. That's this one there. And okay. And it's really annoying that I cannot see exactly which component this is. Okay, that one. Then we have the resistor there as well. This goes to let's actually place this here. Place this one here. All right. Let's see what this one is. This is the test point for the RQ pin. The USB is going to go on the other side, probably somewhere on the side of the board. Okay. So you can see here, this is a typical case where it's good to rewire things. So the ID pin, that's okay. We can have it there, but DP and DM needs to be changed. So I'll remove this one and this one, and then wire it like this. Yeah, like this. I keep going here, but I should be actually going here. Anyway, so update PCB. And now we can just route this directly, which is good. And then the V-bus goes there. So I think the idea is actually that the differential pair is actually going to go in between there. And then it's going to go to the microcontroller. So it's very well designed, this part. This is specifically designed for USB. Can we place this one closer? Okay, this goes there, and where am I going to place this one? So this one is this one will be the bypass capacitor, right? So this has to go to. That sounds weird. Is this the power? Let's see. Yeah, this is the power. Okay, and the second bypass capacitor is going to go here. That's good. And this one connects that pin. Yeah. Actually, we can just place this one here. And this is the main power. So quite likely a good place to have it is somewhere over there. So we have place for these three. They're going to go to the microcontroller. And then we have the outgoing resistors here. Which we'll just place across the lines, across the differential pairs. There we go. And then I think we can just place this whole thing here. This is a very nice fit. So everything just can be very close together. But however, what I'm thinking here is that it's quite likely I actually will change this connector because I would want, ideally, I think, to have the power here. Then I'll just add one pin to this connector, and then I can eliminate this connector. I think that would be ideal. Because both power and and the data are going to be going through the same cable with multiple leads. So that actually makes a lot of sense. And then another little detail is that this one, it would be probably better to make this one a horizontal connector that just lays down and is placed on the edge of the PCB. Just place them both there. That kind of makes sense. But yeah, I'll just swap this. So I'll just do like this. Orientation and mirror. And that's it. So this thing is tiny. Okay, so I'll place this one there. I think there is actually a recommendation in the datasheet, but I'll just place the components for now. I think it's kind of makes sense just to place them as close as possible without crossing any pins. Or any tracks. So these two, this one goes here. Pin number 6. I'm a bit reluctant to place them so close, but I think it could be good actually. Should work. Because they're not actually crossing in terms of the keep out area. And this goes between 6 and 1, so the proper place for this one would be somewhere here. Most natural place. Okay. And then this one. kind of makes sense to just place it there. That's the closest, most obvious way to do the placement in this case. And then we have these ones. Enable pin. And 2 is the input pin. Let's leave some room for it. There. Awesome. What happened to the music? Okay, what's this? Okay, that's good. Like, what is this? Oh, it's that one. Okay. Yeah. This one's not placed though. This one goes here. It just has 2 capacitors on the sides. That's it. So is this one? This one is supposed to be connected to VBus. All right. Oh, it's actually, I just placed them in the wrong position. This is the RS422, not USB. This is USB. Yeah, and since that one is ground, We can just place it like this and then just have a wire to ground. Oh. Okay. So it almost looks like we can place this 3.3 volt regulator right next here. Not too close, but into this space that was left there. So everything fits together rather nicely. Let's see. Yeah, so this will be the output. Okay, that's good. Yeah, gonna almost do like this actually. There's no need to waste space there. Okay, so it turns out that, okay, so this one will go actually just straight through here. That'll be a bit weird. Let's see. I'm actually probably gonna replace this debug connector with something smaller as well. So why do I have 5 of them there? Where's the last? Okay, so it should actually be 4, I think, because we only have 4 power pins. Yes, let's remove one of them. At least for now. So this one is actually the first one, yeah. So I have to make sure that I reserve enough space here, for example, for this pin to be led out, or for this pin to have a via. I should place it like this, and I can place it closer. There we go. That feels a bit weird, that kind of wiring. Yeah. I never get enough time to charge the battery of my camera. I'm using one of these DSLRs, which I don't have any AC adapter for. So I have to use the battery. I'm just gonna put it on charging. Forty 56 is 17. Let's see here. I wonder if it would be a good idea, actually, to wire as many as possible of them here. Let's wire switch number 1 to 14. BA4. Yeah. Okay, then we got 18 and 19. Yeah, this is perfect. So we have 18, 19, and then 5 and 6 there. So probably we can take 5 and 6 on 18, 19. So look which ones are 18, 19. Right, PB0 and PB1. So that's this one there and this one there. And then we have the 7 and 8 are going to go to 10. Let's see. Yeah. This one can go there. And then just no connects there. Awesome. So now they should actually come right to the pins without any crossings, which is great. So we have this RS422, which is actually quite likely to be on the edge of the PCB. Question is which edge. It's quite possible that it's going to be there. Let's move this one there and this one there. Now wait a minute. So this one goes there. Okay, that's fine. And this one is a resistor. Yeah. So this one can go there. That's no problem at all. We have this one. And essentially what I'm trying to do here is to kind of make it as compact as possible without sticking out too much on this side, for example. You can even do it like this. Yeah, that one needs to be there. Let's see here. I think I'm actually going to replace this one on the other side. Maybe I can rewire this one as well. For example, we have 40, 41, 42, 43, 45, 46, all these pins. So look what we have there. Oh, there. So do we have any UARTs here? yeah. So essentially we have UART1, TX, and RX. Usually I use UART1 as the console, the main console for the board. I could use it. I could actually use the main, like this RS422 as the main console as well. I could have this debug console on a different UART. That's easy enough to reassign in the device tree. So let's see here. So I could wire the TX to PB6. Let's see which one we have here. 43 will be RX. They have to be crossed. Okay. Forty 41. How about 45, 46? Yeah, let's use 45, 46. So we can set RXN to 45. Let's actually do like this. So TX.
Sei nicht traurig, tut auch der Abschied weh. Mein Herz geht an Ort und fort muss die Reise gehen. Dein Schmerz wird vergehen und schön wird das Wiedersehen. Ich träg die Sehnsucht fort in die blaue
And 2X will be PB6 and PB7. PB7 for RX. Yeah. Alright, let's see how this looks. So, oh, did I actually end up crossing them? Right. RX and TX and yeah. Yeah, and then for the RX TX, there's no way to not cross them, so they have to be crossed. Or, wait, did I even connect them correctly? So TX goes to PB6. TX, PB6. Yeah, okay, so that was right. And PB7, the RX. Yeah. Okay, cool. Yep. Good. Sehr gut. I'm gonna have some space there so I can just drag these two in between there. And then we can have the ground and this crystal a little bit higher up. Actually, I can have this one here. And I can have these ones going directly in there. Let's see what else I have here, so that I don't so I make sure that I have enough space. It's mainly the power and the USB. Okay, so this one I'll probably change to a different connector. The power will have to take whatever space it takes. This has to work from 24 volts. I could actually have this one. Okay, I think that it's quite likely that this connector would actually do best on the side of the PCB. Something like this. Or actually, no. I can have it like this, because I think the most logical way to get all of this to fit together is to actually have, so because I'm going to have this connector together with the power, it's going to be one connector, I can actually place them kind of like this. And this one is not going to be very sensitive to any noise from the power. Actually, I should be doing like this. So I'll place the filters. I'll place the filters with a connector. So this can filter anything coming out from here. So nothing comes out from here to the transmission lines. And then I'll just combine these two into one. So it's gonna just mean adding another pin to this connector, which is very good. Then we have this one, this jumper. This jumper needs to go here. Oh, I actually thought this jumper was a lot smaller than it actually is. Let's see. Where's the boot pin? Oh, actually, this one can go here. So like this. No, that's not a good place for it. These crystals are huge. I need to find smaller crystals. Okay. How big is this one? If you think about it, it's actually quite good to have a jumper that's a little bit bigger. It's easier to short it. Maybe I could have. Let's see. I could actually move these ones here. I can rotate this one. Yeah, that kind of makes sense. And then, now I can place this one here. There we go. Yeah, that's good. Excellent. Oh, come on. This one fits nicely here. Something like this. What's this? That's the wood color. Okay, so that's actually a bypass capacitor. Oh, and this one actually goes there. You have the bypass capacitor very close to the pin. This is going to require a wire. Not a problem. Okay, let's rotate this one. And then, yeah, and then actually this resistor can be placed here. Doesn't really matter. And then this will go this be placed here actually. Yeah, that's better. Or actually, no, that's not better. There, that's better. So, and this one is with the proof pin. This jumper is just so annoying. It's probably better to just have this jumper somewhere else. So it'll now I can just move this one here. Much better. Make this one better like this. Okay. And all of this stuff is just the debug pins, but there's USB there as well, right? The question is how much USB actually takes in terms of space. Can we move this one here, maybe? I need to have a little bit of space here because I'm going to be... I really want to just drag them out like this. There'll be a few here that have to go side by side. The same is true for this one. But would this USB fit there? Let's see. No, not really. Unless I'll do like this. Let's see, where's the PCB edge? Oh, okay. So let's say we would have PCB edge there. It still doesn't really fit here. Let's move this one here. I can actually start placing some edges here now. So I'm going to go to the edge cuts and just place some edges. And the form factor of this PCB is rather open-ended, so there isn't really any kind of requirement to fit into a certain space. Okay, I can't move this one there. I'm gonna leave it there for now. Okay, so that's going to be a keep out on all layers. So this isn't actually supposed to be, this is a non-plated hole. So it's going to have copper around it, but it's not going to have any copper on the inside. which is precisely what we want. So it's gonna go pretty much like this, and because because this one will be sort of, it'll just be another extra pin. It's gonna be a slightly bigger connector. So I'll replace this connector, and then everything can just fit in like this. Okay, now it's only the debug port left and the USB connector.
Wo findet dies Schauspiel statt? Im fernen Land, in ferner Stadt. Wirst du dann tun, was jeder tut? Was lange währt, wird endlich gut.
Okay, this one is just connected to the V-bus. So yeah, we can just take all of these components and redistribute them. It's going to work really well. And actually, even this one can go, because this is going to be filtering the V-bus, so it can go through the bead and through the diode and then into an internal layer. So the diode can actually be here. That's better. All right. And then I'll just move this one slightly closer there. Something like that. Except that the debug connector would be best put here somewhere as some kind of, like, maybe even a PCB edge connector where you just solder a header surface mounted 2.54 and just place it here, and then you have all the debug pins here. I think in this case it would probably be the best solution instead of using my standard connector. Yeah, let's see what we can find actually. So I have my, let's see, footprint editor. Is there any connector that is SMD but not, but just one row? Vertical. I wonder how big those pins are. I actually have to find the pin header and check. And we can just make my connector footprint for it. So the idea is basically to just solder it on the side. So if I would have like pads on the edge of the PCB, and then I just solder the pin header on the side, because this is only going to be used for debugging. And it would even be possible to just hold it in place and program the board without actually soldering it. So that's a good solution, I think. I'm just going to measure how much the pins are sticking out, so I know how big pads I need to create. So around like 3.66 millimeters. Sounds reasonable. Like 3.3. I think I'm gonna make the pads 3.3 long. So let's create a new connector footprint for this debug thing. Let's see. Where is that connector? Let's see. What connector is this? Debug 2R. Why do I not see debug 2R? Let's see. Ah, because it's using this one. Okay. I'm just thinking if I should create a new a new symbol for it, which would kind of make sense. I could actually create a new symbol for a new type of debug connector that I will just map specifically for this STM32F103. So I might actually have some use for it in a different design. So I'll just map the pins so that they connect directly to all of these debug pins like SVO, SW clock, SVD IO. Let's see, we got SVD IO there, and then I'm just gonna place it here. Let's see if we have enough space here. We have 2. Damn. So 3.3. That's how much it's gonna stick out. So that's quite a lot. Might need to move this one. Okay, I could actually make the pads a bit smaller, but not too small. Or I can actually move the whole thing here. That's going to sort itself out. Okay, so I'm going to go to my component editor here. And I'll just take this con debug and let's see. Or actually, let's actually do like this. So this one can go with that one. And I can just do it in the... No, actually, it is the proper thing to do to copy it, because it's going to be 2 different footprints. I still want to use the old one. Yeah, so I'll just do like this. And it's going to have the same schematic symbol, but it's going to be... But it's going to have a different footprint. So new footprint. And then just pads like this. I wonder if 2 would be a good width. Let's see. I'm going to set the grid to 2.54. Just so it's easy to place the pads. That's a bit better. Let's make it 1.6. Yeah, that's good. Actually, I'm gonna try to measure it and see. So the pin is 0.65. So it's actually 1 millimeter would be would be plenty in this case. Let's make it 1.2 to have a little bit extra pad area. Oh, actually, I'm going to make it 1.3. It's always good to have some extra pad area, because pads can actually break off, especially in a constellation like this, where you have the connector soldered on the side. Even though this is not a connector that's going to be normally used, it's only going to be used for debugging. Still, it's going to be putting a lot of stress on the pads. And what if I actually place, I can have the silk screen on the back actually. That's a good idea. So let's just place some placeholders here like that. Yeah, that's really good. But first though, I'm gonna just make sure that all the pins connect properly and stuff. So I don't have to cross too many pins. So I'll just save this one, and then I'm gonna swap out the schematic symbol. So let's see. Let's save this one. And then I'm gonna swap this one out. Oh, actually, a good way to do it is to just open this and then con debug F103 CD. That's it. And then update all the fields. And now we have a new connector here, which is so much easier to handle than the previous one. It's just a bit big. Okay, that makes sense. And then just place this one here. And you can see that a lot of pins are very easy to connect now. So you have reset. Reset is the only one that goes to the other side there. We have the SVD IO, SVD clock, and actually most of them just connect directly. So this is very good. This works right out of the box. So just one more thing here. I need to take this bead and place it here. Actually, I shouldn't be placing the components so close to the edge of the PCB. Okay. Starting to look like a like a PCB, like an outline of PCB. Of course, there's a lot more work to do, and I need to add all the ground fill, the power planes. Have to make sure that all the holes are aligned properly. Yeah. And then, of course, I have to start routing this PCB, and I'm probably going to discover some places where I have to move components a little bit to make sure that there is enough space. But I think for the most part, this is going to look very good. And this one will go on the back, just straight to here. It's going to be on the the transmission lines are going to be on the other side of the ground plane. So they're going to be a little bit shielded from this regulator. Shouldn't be a problem. And another alternative here is actually to also place these connectors like this, and have them and change them to the horizontal ones. Yeah, that's actually very good. Yeah, and this one will go, let's see, this one should be the first one, and then this one be the second one. All right, that's it for this video. Thanks for watching. Bye.